So yesterday we see the operators for relational algebra. So today we are going to see how to solve a given query using relational algebra operations. Okay, so we are going to write the expressions to solve the queries. The first query, I have already written the relational algebra expressions here because this sigma and all they are means I'll just tell you how it works. You can write it in a single expression. I already told you. You can solve a query using a single expression, or you can solve it in multiple expressions. So in the first query, what we are going to retrieve is to retrieve a list of names of female employees dependents. Okay, so this is again the company database. So we are going to retrieve this from the company relational model. Okay, company relational model, we already know, we already have that particular thing. So what we are going to retrieve is dependent's name. Dependent is going to be the dependent for female employees. Retrieve names of female employees dependents. Okay, so that means we first need to retrieve the details about female employees, isn't it? We need to retrieve details about female employees. After that, after getting that thing, we will join it with the dependent. Okay, we will join it with the dependent in order to get the details of the female employees along with the details of their dependents. Isn't it? In the after joining, we'll get the details of the employees, female employees, along with the details of their dependents. So from there, we can retrieve the name of the dependent. So here, the same thing. I'm first in the first solution that I have written here. I have used 3 expressions. So in the first one, the female employees details of the female employees are retrieved. Okay, by using the sigma. So we know that sigma is used for retrieving tuples, isn't it? So from the employee relation, we are selecting the tuples which has the value f for the attribute sex. Okay, so that means we are retrieving information about the female employee. So this we will place it to a relation, resultant relation. We name it as FEMP. Okay, like female employee. So we have a relation here. Now, in order to get the dependents for this female employees, what we need to do is we need to join it with the. We already know the definition for join. So we need to join it. Now the thing with what we are going to retrieve a list of names of female employees dependents. So we just need to retrieve the dependent name, isn't it? So we'll retrieve by using pi, that is projection. We'll retrieve the name of the this one dependent. Okay, so that will be the result. So I'm just placing it in a result relation. Means that I'm just naming that particular resultant relation as a result. Okay. So in this way, by using many expressions, you can solve a query, or in a single. This is also same as this. The only thing is I'm just concatenating. I'm just nesting up the expressions one after another in order to get the solution for the given query. Okay. So the same thing in the first means in the innermost this one expression. What I'm doing is I'm accessing, retrieving the details about the female employees. After that, after retrieving it, I'm joining it with the dependent, and after that, project means I'm just projecting, retrieving the name of the dependent. Okay, so you can solve it in a single expression, or you can solve it. Depends on you, which is more comfortable to you. You just choose it. If you want to use a single expression to solve the problem, then you can use a single expression. If you want to, means if it is confusing to you, if writing a single expression is confusing to you, then you can divide it into multiple expressions in order to solve the query. Okay. Now let us see the next query. Retrieve the name of employees who work on all the projects that John Smith works on. Okay. So here one thing, let us read this again. Employees who works on all the projects that John Smith works on. That means if a person say for example, first let us say John Smith works on project number 1 and project number 2. Okay, then we are going to retrieve the other employees, the other remaining employees who is working both on this project number 1 and 2. Okay, so such as for example, a particular employee A, if he or she is working in project number 1, 2, 3, and then it means this project number, employee, this particular John Smith is working. Okay, so from here we only need, I already told you we are going to perform division operation, isn't it? That means we only need the project number, we do not need the other details. Okay, so that is why we will project only the project number. We'll project only the project number and we'll store it in Smith project. Okay, so this Smith project will have all the numbers for all the projects in which John Smith is working. Okay, after that, this particular expression, this one means you can even without projecting this to even by division operation between works on and Smith project, it will work. But still, the only important thing that we need is the SSN value of the employees who is working in the same project as John Smith is working, isn't it? So that is why I'm projecting ESSN and project number only from works on in order to get it. Okay, ESSN project number. What we are going to get is so P&O from here, from this expression, this Smith pros will contain P&O, only one attribute, that is P&O, because of this pi. And if John Smith is working on project number 1 and 2, then we'll get like this. Okay, Smith project will look like this. Okay, and from this from this expression, the resultant relation, that is employee project, will have two attributes, and it might have some few values like this. And the attributes will be ESSN and P&O. Okay. And it will have all the SSN value for all the employees along with the project number where he or she is working. Okay, let's say this is going to be ESSN, not the name of the employee. So 123 203, like this, some values will be there. Again 123, again 203, 203, 444, 555. Some few values like this. Project number 1, 1, 2, 5, 2, 1, 5. Okay. Some values like this might be there. Okay, in employee project, in this particular resultant relation, this employee project. So after retrieving only this ESSN and P number from box on, we'll get a table like this. We'll get a relation like this. Now, from here, from this two, by using this two relation, we will means it will be easy to get the SSN for the employees who is working both in project number 1 and 2. Okay, by using the division operation, isn't it? So we use this division operation, employee project division divided by Smith project. Okay, so we'll get the ESSN value like that. And ESSN 2 means 2 ESSN will be retrieved. The first one is 1, 2, 3 because 1, 2, 3 is associated both with 1 here in the first tuple, and in the third tuple again it is associated with 2. So 1, 2, 3 will be retrieved. Okay, and another ESSN will be retrieved, and that is 203 because 203 is again associated with 1 in tuple number 2, and again it is associated with 2 in tuple number 5. Okay, so this 2 ESSN will be retrieved. Okay, and other remaining ESSN like 444, 555, they are not going to retrieve because they are not associated with both this number. Means 444 is associated with 1, but there is no such tuple where 444 is associated with 2. So that is why it will not be retrieved. And 555 is not associated with both the value, that is either 1 or 2. Okay, so that means this 2 SSN value, that is 123 and 203 will be retrieved. And it will be placed here in employee SSN. Okay, now this employee SSN, in order to get the details, means we are going to retrieve the name of employees, isn't it? Name of employees is going to be the first name, middle name, last name. So that we can get it from the employee table. So for that, we will join it again with the employee table, and after that we will retrieve first name, middle name, last name. Okay, and we will place it in the result. Can you see any problem here? Any doubt? There is something here. There is we need to have another expression in between here. Can you guess it? Anyone? What is it? Okay, so when we retrieve SSN and P number from works on, even the SSN and P number for John Smith will be retrieved. Okay, here someone who is having project number 123 or 203, whatever might be the SSN value for John Smith. But from the query, retrieve the name of employees who works on all the projects that John Smith works on. That means we are going to retrieve the other employees who is not John Smith and who is working on all the projects where John Smith is working. Isn't it? That means from in this result, even the name of John Smith will come. Okay, name for John Smith is going to be retrieved because it works on contains SSN and P number of John Smith also. Okay, so for that here in between, whether you can have either or after doing this you can remove it. Means you can you can have a sigma and you can get the here After this expression, you can have something here like EMP equal to sigma oh okay. So first name not equal to John, last name not equal to Smith from uh, from employee, and from here from this EMP instead of joining with this employee. You just get details about the other remaining employees in EMP, and after that, instead of joining with this employee, join it with this EMP. Okay. Only at that point of time you will get the first name, middle name, and last name of other remaining employees who is not John Smith and who is working in all the projects where John Smith is working. Any doubts? Are you people able to understand whatever I'm saying here? What I have done here, do you able to grasp it? Don't you have anything to say? Am I clear? I can't hear you people.
Yes, ma'am, clear, ma'am.
Okay. So then you try this one. You try this retrieval query. Try to solve it using relational algebra. Retrieve the name and address of all employees who work for the research department. You try it and you can send it to the WhatsApp group. Okay, so we took the name and address of all employees who work for the research department. So here, research is the name of the department, isn't it? And this D name, there is a attribute D name in the department relation. Okay, you need to remember the company relational model. So you just keep the company relational model there with you all the time. So from there, what you need to do is from the department table, from the department relation, select the tuple who is having, means select that particular tuple who is having the name equal to research. Okay, by using sigma, select the tuple where the name is equal to research. Okay, and you join it. You join this resultant relation with the employee. Why? Because we are going to retrieve name and address of employees who are working in the research department, isn't it? So you join it with the employee, and the joining condition is going to be department number equal to department number. Okay, there is a DNO value in employee table, isn't it? Same thing here again in the resultant table of this research department, you will have a D number. So as we are going to retrieve name and address of employees who are working in the research department, the D number in this employee, means those employees, is going to be same as the D number for the research department. So for those tuples, we are going to retrieve name and address, isn't it? So we'll join it. After that, we will project name and address. Okay. Now you just try it and you can send it later on. Now this one, try this one. For every project located in Impal, list the project number, the controlling department number, and the department manager's first name, address, and birth date. I think this query we have already solved it using SQL. Now you have to solve it using relational algebra. You need to access three tables here. One is project, another one is department, and another one is employee. You will get project number, controlling department number, and this project location in the project relation. And by using dnum, you will get mgrssn from the department table, department relation, isn't it? And then by using this mgrssn, you will get manager's first name, address, and birth date from the employee relation. Okay, try this. So try this two query, and the other remaining query will do it in the next class. And one thing I told you in the yesterday's class, I told you that there will be a unit test this week, isn't it? Now let us do it in next week Monday. Okay, we'll complete it this week, means relational algebra, and next week Monday we'll have unit test. And another thing, in the lab classes, I think you people are asking for creating whether whether to create a single table or one or more table and again. Okay, this you should. I mean, this you are in this. What it means, you are already in this stage that you do not need to ask those things. By just getting the requirement specification or whatever things you have given, you just read those things, whether it is the query that is given to you or whether it is a requirement specification. You just analyze it and you should be able to design it. If you got the design, then you will know whether to create a single table or two or more tables. Okay, you have to apply the constraints also. So if you are not, means if you are not able to apply those constraints, then your model is going to be a wrong model. You will not be able to solve the queries that is given to you. Okay, so try that yourself. Analyze it. If you are not able to analyze, then after that you can ask. Means it is means it is not whether, means without looking there, asking how many tables to create, whether to create a single table or a two table or a three table. I don't think it is means you are not, means you are already, we have done it in the first two three classes designing process. So you should not now ask it. Or if you have doubts in analyzing the requirement specification, then only at that point of time you can ask. You can ask me for that. If you have any doubt in designing your database, then you can tell me.
Ma'am, in the lab we can design it as per our convenient, as we thought it is to.
Means whatever queries that is given there, you
Yes,
just
ma'am.
analyze it.
Yes, according to the
Yeah,
query we can create
yeah,
the
you
data.
can analyze it and then you design it. Okay. Any other thing? So unit test next week Monday. The topic is on SQL only. Okay, you need to develop your means query writing skills. So just try to practice it a lot, and then we'll have this unit test only on this one SQL queries. You have to write only SQL queries in this unit test. And for your attendance, you just, means in the chat box, you just type in your name and enrollment number. And after that, you may leave. Solve these two queries and send it